Hello and welcome to Open Logic. In this video, we will continue on DRAM by looking at dual inline memory modules DIMM and the concept of channel and rank. We started off this series by looking at memory cell. Using memory cells, we can form memory array, and several memory arrays are used to form a bank. And this is where we left off previously. Now several banks can form a bank group, and several bank groups form one memory chip. Depending on the technology or configuration, sometimes bank group doesn't exist, and you will have a memory chip consisting of banks only. This is a memory chip of 4 bank groups, and every bank group has 4 banks, whereas this one is one memory chip of 16 banks. Several memory chips are used to construct a DIMM. On the next level is a motherboard. It can contain several memory slots where we can insert the DIMMs. And that's it. This is the view of a memory system from bottom to top. This is a structural hierarchy view, and there is another way to look at memory system, which is from its addressing hierarchy. These are the terminologies used in addressing: column address, row address, bank, bank group, rank, and channel. Most of them are pretty straightforward. Let's say we want to access the data on address 0. We provide column address 0 and then row address 0, and now we can access this chunk of data. There are several banks, and therefore we will have to select bank 0, and on the memory chip level we will select a bank group 0. Or in the case where there is no bank group, we simply select bank 0 in the memory chip. Now this should be pretty easy to visualize. However, rank and channel are not so visible from these diagrams. They are not represented by DIMMs or memory slots. Alright, let's start by understanding channel. First of all, pardon me for a very bare diagram, but let's move on. A motherboard can have one or more memory slots where you can insert DIMMs. Let's say we have 4 DIMMs. Each of them has 1 gig of memory. So in this system, we have 4 gigs of memory. This system can be designed in such a way that it has only one channel, and this one channel supports 4 gigs of memory. Or it can have 2 channels, where every channel supports 2 gigs of memory. Or it can have 4 channels, where every channel supports 1 gig of memory. Let's look back at this 2 channels system. There is an interesting setup. Let's say we only have 2 DIMMs. We can choose to put these 2 DIMMs into one channel, or we can put one DIMM in channel 0 and the other at channel 1. Generally speaking, one of these setup has an advantage. Do you know which is it? Well, this 2 channels setup is better. The reason is that every channel is accessed independently. Imagine if you are playing a game on the computer. The gaming data can be stored on channel 0, and at the same time you are also loading a video on a browser, and the video data can be stored at channel 1. Because of the 2 channels are accessed independently, these 2 activities can run smoothly. However, if you put 2 DIMMs on the same channel, the 2 activities would be competing for the same resource, and they could run slower or they can be lagging. Alright, that's memory channel. Now let's move to memory rank. This is a DIMM, and it is a device for storing data. To write to the DIMM, you need to provide an address and then the data. Reading from it is the same, but the data is returned from the DIMM. Generally, that's the functionality of a DIMM. In the latest technology, there are DDR4, DDR5, LP4, and LP5. DDR4 accesses data in 64 bits chunk, and DDR5 accesses data in 32 bits, and both LP4 and LP5 access data in 16 bits. Let's concentrate on DDR5. As you can see, DDR5 accesses data in 32 bits, but if you look at the bank, in this case, it only handles 4 bits of data. So how does DDR5 DIMM handle 32 bits of data? Well, it's the same relationship between memory arrays and bank. One memory array provides 1 bit of data, and we can use 4 memory arrays to form one bank, and that one bank handles 4 bits of data. Similarly, every memory chip provides 4 bits of data per access. In order to get 32 bits of data, we use 8 memory chips. If you remember from previous video, a bank can be by 4, by 8, or by 16. If we are using by 8 memory chips, we only need 4 chips to form a DIMM. And if we are using by 16, we only need 2 of them. To summarize, a single memory chip does not operate independently. Several memory chips form one memory rank. In another word, a 32-bit data is chopped off and every chunk is handled by a memory chip. Now a DIMM can be designed in such a way that it only has memory chips on one side and on the other side it is empty. This kind of configuration is known as single rank. A memory DIMM can also have a different set of memory chips at the backside. This gives a second rank on the memory DIMM. It is also known as dual rank. Now let's get back on the motherboard system. Let's say we have 4 DIMMs and every DIMM is a single rank. This would be a system of 1 channel and there are 4 ranks per channel. And this would be a system of 2 channels and there are 2 ranks per channel. And this would be a system of 4 channels and there is only 1 rank per channel. If the DIMMs are dual ranks, it simply means the number of ranks are doubled. Now adding ranks only increases memory capacity on the channel. It generally does not increase the system speed to process data. Whereas if a system has more channels, it can process data in a parallel manner and therefore it is faster. Or it can support multitasking better. If you like this video and want to see more of them, don't forget to like, share and subscribe.